Hi there. Today I'm going to talk about adhesive bonding. Before we start, I would like to introduce some things. There are a lot of joining process we need to choose regarding to the material and also the parameters. So today I'm going to focus on adhesive bonding. Adhesive bonding can be known as gluing or glue bonding. It describes a wafer bonding technique with applying an intermediate layer to connect substrates of different materials. The connection can be soluble or insoluble. In analogy speaking, we can say that the substrates can be the bread of sandwich and the adhesive can be the layer, just like the image. So this one, the bread can be the substrate, layer as the adhesive, and also another bread. So with this, and it can only become the very delicious sandwich or our desired product. The reason, no, it's the reason. The reason many people choose adhesive bonding because it can be operate at low temperature below 200 degrees Celsius. And the most established adhesive are polymers. There are four important parameters to produce high strength material. First, structure of adhesive point. Second, adhesion, wetting, and also last, failure of adhesive bonding. For adhesive joint, it's a concept of two substrate surfaces with the adhesive material fill the gap between them. So, as we mentioned just now, for the bread of sandwich, the first bread, the substrate one, the next is the mayo, or if let's say you have to put some mustard is okay, and also the next bread, substrate two, with at least three components here, you can only consider adhesive joint, adhesive bonding. So, where is the boundary? Boundary layer is a part of adhesive layer adjacent to the substrate surfaces. So it will be between the adhesive and the substrate. The adhesion. Adhesion is a complex of physical chemical processes occurring at the interface of two materials brought into an intimate contact. It will form the very strong attractive force between the two materials. There are several factors affecting the adhesion. Mechanical. The mechanical refers to the porosity or rough surface. With the porosity and rough surface, it provides stronger adhesion. It's because it will have a larger interface area and it can interlock the adhesive material in the surface microwebs. So for the chemical, in covalent bonding can be formed between the two materials with similar electronegativities. For ionic, is different from the covalent. Ionic bond can only be formed between two materials with different electronegativity, which greater than 1.7. For intermolecular bonding consists of hydrogen bonding and also van der Waals forces. For hydrogen bonding, it's an intermolecular bonding formed between an hydrogen atom chemically bond to an electronegative atom and another electronegative atom of a neighboring molecule. The van der Waals is a result of electrostatic attraction between the neighboring molecules having permanent or instant transient dipole groups. The diffusion. Diffusion is a very important factor if the adhesive and adherent materials are similar and their molecules are mobile enough and capable to move across the interface. Wetting. Wetting is a process of spreading a drop of liquid over the surface of solid substrate. It's just like we are having glue here. If let's say we're having glue, we're switching in a very nice strip like this, it will cause only partial wetting since there's nothing here. So we can conclude that this part we cannot stick with another substrate. So for the point of view of angle, if let's say we want to have a very good wetting, the wetting angle should be below 90 degree. And let's say we have a partial wetting, we only have more than 90 degree but lower than 180 degree. So this is the failure of adhesive bonding. There are three types of failure in the bonding. First, the structural failure. Structural failure refers to the internal failure of a substrate material in a region close to the joint. So this is a structural failure. So if the failure happens only in the substrate, but not in the adhesive layer. The next, adhesive failure. Adhesive failures is an intervention failure resulted in the separation of one of the substrate from the adhesive layer, which means that adhesive failure happens in between the adhesive and the substrate. You see, there will be the gap here. Cohesive failure. Cohesive failure only happens in the internal failure of the adhesive layer. So this is a cohesive failure. So it's a failure happens inside the adhesive layer. In order to produce adhesive bonding, will be 4 steps. First, cleaning. Second, apply the adhesive. Third, contact the 2 or more substrates. Fourth, hardening the intermediate. To clean the substrate, what we need for a desired product is the weak boundary layer to the given material must be removed or chemically modified to create strong boundary layer. It shows that we have to remove all the contaminant on the surface. Second, the surface energy of the adherent should be higher than that of the adhesive for good wetting. So the surface energy is higher so that if not, it will stick. It will perform a below 90 degree wetting angle since the cohesive force is bigger than the adhesive force of the adhesive layer. Third, the surface profile can be improved to provide mechanical interlocking. This one is regarding to the porosity of the surface. There are several ways to produce desirable surface: degreasing, abrasion, and purify. For degreasing, the oil contamination must be removed to form a strong bond. The solvent used and the adherent must be considered to prevent irreversibly damage of the surface. Abrasion. The surface can be sanded or grit blasted with an abrasive material to roughen the surface and remove any loose material. It helps to increase surface area for the adhesive to bond. By roughening the surface, it helps to increase mechanical interlocking. For pure pipe, a thin woven piece of material is applied to the adherent during fabrication. It will leave a tortuous surface when removed, and it improves bonding by mechanical interlocking. Other than that will be flame treatment, chemical treatment, and ultraviolet radiation treatment. BCB, benzoyl-cyclobutene. It is a hydrocarbon that is widely used in electronics. It exists in dry ash and also a photosensitive version, each requiring different procedural steps for structuring. But the procedure for dry edge BCB are cleaning, supplying adhesive promoter, just I say, drying the primer, and BCB deposition. So this the four steps before is similar to all the adhesive bonding. But the next for photosensitive BCB here, after we include a layer of BCB here, we just let it expose and develop by itself. But if let's say it's dry edge, we have to apply some energy, and after that we have to let exposure and let the development of resist mask. After that, the pattern transfer to BCB by dry etching. After they having the complete one, then we can stick our next substrate on here. BCB is widely used because it releases only small amounts of byproducts during the curing, which enables a wide free bond. It produces very strong bonds and excellent chemical resistance to numerous acids, alkalines, and solvents. The BCB is over 90% transparent to visible light, which enables the use for optical applications. There are some advantages and disadvantages for adhesive bonding. For advantages, for the first one is not affected by heat. Stress is well distribution. It can join the large surface of different materials. There's no precise fit of adherent surfaces necessary. It shows good damping properties and high dynamic strength. Since the temperature of operating is low, the material structure of the adherents to be joined is not macroscopically affected, and the deformation of internal stress, which generally are related to the application of heat, is rarely occurred. It can say that it can be bonded without any heat supply. For disadvantages, it has limited stability to heat. Long-term use may alter the properties of the bond line. Cleaning and surface preparation of the adherents is necessary in many cases. Specific production requirements to be met. Non-destructive quality testing. For the first one, limited stability to heat. It shows that it's relatively poor heat resistance of the bond line as compared to the inorganic materials such as metal and glass. In order to obtain a high performance assemblies, the production parameters must meet the specific requirements of the material used. For the last one, there's a little non-destructive quality testing for us to test whether the quality, the properties of the final product after the adhesive bonding. So I have explained about the formation, advantage and disadvantage, how to prepare. I hope you guys can understand about it. Thank you.